Alright, so Module 8 is all about circles, and I've split it up into two. So the first one is we're just going to talk about using properties of segments that intersect circles. So we have a lot of vocab in circles. The first one is just what a circle is. It is a set of all points in a plane that are equidistant from a given point. So that's where the radius comes in. And the center. So the center is the point where all points are equidistant, so it's the middle of the circle. And the radius is the segment that comes from the center to any point on the circle. So that's how the circle is formed, is that the circle has the same radius always, no matter where you draw it. So that would be AC, if you look at my picture on the left. A chord is a segment whose endpoints are on the circle. So I drew a segment, A and B are on the circle. A diameter is also to a segment that endpoints are on the circle, but it contains the center of the circle. So it goes through the center and it's a segment. Secant is just like a chord, but it is a line, so it extends in both directions. So if you see, I have line AB instead of segment AB, chord versus secant. And then a tangent could be a line, ray, or segment. It could be either one. And it intersects the circle at exactly one point. And that point is the point of tangency. So in my picture, I have D, and that is a line. And it's a line ED, and D is your point of tangency. Common tangents, it's a line, ray, or segment that is tangent to two circles. So this one is called internal over here. Sometimes they'll say internal or external. It's not a big deal, but internal means in between the two circles. External means outside the two circles. So that is all the vocab for a circle. So, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent to circle C. So BC. So if I look at segment BC, that would be a radius because it goes from the center to the edge of the circle. EA. So E is here and A is here, so it is a line that goes through the circle, so that is a secant. And then DE is a ray, so it starts here and it goes this way. That is a tangent. Alright, give the name that best describes the figure. So I want you to go through, look at the diagram, see if it's a line, segment, ray, point, and then draw the, write down the name. Good luck. Alright, check to see how you did. The first one is a line and it goes through the circle, so it is a secant. The next one is tangent. The next one is chord. Then center, diameter, radius, point of tangency, and common tangent. And if you need more descriptions of those, rewind the video and listen to that first part again. Okay, so now we're going to talk about some angles in circles. So a degree in a circle, so if you go all the way around a circle, we are going to get 360 degrees. A central angle is angles whose vertex is the center of the circle. So if you look, I drew a central angle. So angle ACB would be a central angle. The minor arc is part of a circle measuring less than 180. So this right here would be your minor arc. So notation is two letters, so A and B, and you put an arc above it. The measure of your minor arc is the same as the measure of your central angle. So if I would say that this central angle is 60 degrees, your arc is also 60 degrees. Oh, whoa. Okay. So now major arc is between 180 and 360, so it's more than half the circle. So if I look, this would be my major arc. And you label it with three letters now. A, D, B, because I have to go to D to B, go all the way around the circle, and you put an arc above it. So it has to be 3 letters. Semicircle, notation, you have to do 3 letters as well, because I don't know which way if you're going to go above or below in this case. So you need to make sure that you do 3 letters. E, D, F. And a semicircle is half a circle, so it will always be 180 degrees. All right, so tell whether the bold arc is a minor, major, or semicircle, then name the arc. So try these 3, and then we'll talk about them. All right, so we have semicircle, P, S, Q. You gotta do 3 letters. All you do is just go in a circle. So P to S to Q. Minor arc, because AB, you just do 2 letters. And then major, because we're going around the circle, go through D, so it would be ADB. All right, so now this next postulate we have talked about a lot in other forms, but now we're going to talk about it with angles, or with arcs, sorry. So we have talked about part plus part equals the whole, and that's exactly what this is. This is my whole angle. This is part of it, and if you add up another part, it equals the whole. So if I look at AB, oh, I wanted a highlighter. So if I have AB and then BC, I'm going to get this whole angle. So this whole angle would be ABC. BC is my part, and AB is also a part. So part plus part equals the whole. So we have a problem that looks like this. It says AB and FE are diameters. So I know that this right here is 180 degrees because it's a semicircle, okay? I also know that this is also 180, F to E. But determine whether the given arc is minor, major, or semicircle, and then find its measure. So A to D. So if I want to find this arc right here, I know that the central angle is 57, so this is also going to be 57 degrees because the central angle is the same as your arc. And since it's less than 180, it's going to be minor. AE now, go from A to E, is going to be 57 plus 63. So what is that, 120, I believe? And that is still a minor arc because it's less than 180. Now, FDE. If I look at I'm going to get rid of this here because I need to look at the other one. FDE. It also says FE is a diameter, so that is also 180. So this is going to be 180. And 180 means it is a semicircle. Now, here's a little trickier part. I have to come up with EB. Well, if I look, this whole angle here is 180. So now I just have to subtract from 180, 57 and 63 to get your angle. So that would be 60 degrees. And that is a minor. EAB. Now here's the tricky one, because I would need to start at E and I need to go all the way around to B. So this whole thing I need to find the measure of. Now, there's an easier way to do this rather than adding up all those angles and then you also have to find this angle. So, the easier way to do this would be, I already know that this is 60 degrees. So then going from all the way around, if I know the whole circle is 360, I can just do 360 minus 60. And I get 300. And that would be a major arc. So using your knowledge of the whole angle is the whole circle is 360, you can find by subtracting, you can find different angles. A central angle, remember, is the angles whose vertex is the center of the circle. We are now going to talk about inscribed and intercepted arcs. Inscribed angle means now the angle is on the circle, not in the center. So that is your inscribed angle would be angle ABC. The intercepted arc would be arc AC. So the arc would be this arc right here. That is your intercepted arc. Your angle is 1/2 the arc. And we're going to be talking a lot more about that in our next video. So your angle equals 1/2 the arc. So if I look at here, my angle is angle A. It equals 1/2 the arc, which is 158. So the measure of angle A, I take 1/2 times 158, and I get 79 degrees. This should have an arc above it. So your angle is 90 equals 1/2 the measure of BC. So you can divide by 1/2, which if you remember, that's the same thing as multiplying by 2, so that's going to be 180 degrees. So this is going to be 180 degrees. So you try these next two, see if you can come up with the right answer. Alright, that last one was a tricky one. I did that to trick you. The first one, so I have your angle equals 1/2 the arc. So then I divided by 1/2, so I get 80 degrees. This next one is a central angle. The angle is not on the circle like A is over here. It's in the center. That means that it's equal. So that's the biggest thing to forget, is that you know the angles and the central angle and the arcs are equal. We're going to skip this one. Okay, I want you to find the measure of arc BC and the value of x on the bottom too. So do this as a little quick check to make sure you understand the concepts. Alright, we're first going to go over the first one. So if you see AB is a diameter, so I put that in green, is I know that the arc ACB is 180 degrees. Now I also know that angle B is 64. So if I need to figure that out, so my angle is 64 equals 1/2 times the measure of AC. So divide by 1/2, which is the same thing as multiplying by 2. So 128 equals the measure of AC. So that's how I got 128. And now I just need to do subtracting. So it is just a simple 120 part plus part equals the whole. And then I subtracted to get my total. Alright, so my last two problems, making sure you know the difference. Here's a central angle, so I know that it's 33. The second one is an inscribed angle, so I know it's 66. So you double to find your arc, or you take the half to find your angle. You can always set it up as an equation like this, so you never have to guess to know how to solve. Now there's some practice. Good luck.